So in today's lecture, we will discuss the questions related to the pressure variation due to the depth. Right. So this is the concept. First you write hydrostatics paradox. Right. The condition is that suppose there is a vessel, right, different type of the vessel. Suppose this type of the vessel is there, right, like this, all right, and like this. Suppose this type of the vessels are there, right, and you fill the liquid in any of the liquid, right. Also, it may be tilted like this, right. It may be tilted like this. Fine. So when you will fill the water or the liquid, the level of the liquid will be similar. Is it clear? So according to the hydrostatics paradox, listen one thing. If you choose any point, this is the P1, this is the P2, and this is the P3. So at any horizontal level, right, the water will be, the pressure will be the same. At any horizontal level, condition is that liquid is at rest. If liquid is at rest, not accelerated, right, at any horizontal level, pressure in the same liquid will be same. Is it clear or not? And therefore, if pressure is same, suppose this is the pressure P2 at this point, this is the pressure P1 at this point, and this is the pressure P3, or you assume this is the P2, P3, and this is the P4. Understood? So P1, right, P2, P3, P4, if the same. So if this is the P0, so it must be equal to the height h. If this is the pressure, whatever the shape of the column is, liquid column is, so the pressure P2, because P1, P2 and P3 and P4 also at the same. This is called the condition of the hydrostatics paradox, right? And what is the P1? P1 is equal to P2 mean the P0 plus H rho g, and P2 is equal to what? P0 plus H rho g. Is it clear? And in the same way, the P3 and the P4 also, right? P0 plus H rho g. Therefore, the height rise in the column will be the same. Suppose this is the height rise, right? Whatever the shape, whether it is big in cross section or less, the weight of the liquid column may be the different. For example, the weight of this liquid column is more and weight of this liquid column is less, but the pressure at this point depends upon the height, and therefore it is same. In the same way, if you consider this the vertical tube and this is the at angle and any angle theta, so if you consider the x, right, the length rise in the x, but the height will be the same. So what is the relation? If you solve this type of question, this question comes in the exam, right? So the sine alpha is equal to what? What will you say? H upon x. So x will be equal to h upon sine alpha. So this is the length of the water column in this tilted tube, right? The x is equal to h upon sine alpha if h is the height, right? Copy this. So in this question, first of all, we have a U tube and the cross section area. If the area of cross section is A, the area of cross section is 4A this side. You have to understand this, right? Because on the left is 1/4. So this is A, this is 4A. Initially, the mercury is filled in a level. Mercury is filled in a level mean the mercury is in the horizontal level in both limb, right? And this is open to air. Is it clear or not, you tell? And according to the question, the level of the mercury narrow tube limb is at a distance 36 centimeter from the upper end. This is the upper end, and the level of this mercury is 36 centimeter in the narrow limb. You understand or not? So what will happen? Initially both are equal at equal level, right? And now when you fill the water, what will happen? Tell me. This level will move down and this level will move up, right? Suppose listen one thing. Suppose now this is the narrow limb and this is the big limb, right? Now the mercury comes in this level, right? Like this. This is the mercury. The mercury is much denser, and the decrement in the level is x1, and the increment in the level is what? Say x2. So the mercury comes in this way, and the water is, this is the water, suppose. Is it clear or not? You tell. Fine. This is the water. All right. So what they are asking? They are asking in the question, what will be the rise in the level of the mercury in the right limb if the left limb is filled top of the water. So they are asking how much rise is there in the right limb. So what they are asking? They are asking x1, x2 or x1 plus x2. They are asking rise in the mercury level. This is the rise in the mercury level, right? The rise in the mercury level mean this is x1, right? And this is x2. So they are asking the x2. First of all, it should be clear. Is it fine or not? You tell, Varsha. The x2. Now, if you consider the concept at the same horizontal level, in the same liquid, the pressure must be the same, right? So if I consider this the point 1, this is the point 2, right? So the pressure P1 and the pressure at P2 must be the same. This is how much? This is the 36 centimeter, right? And this is x1. So what is the pressure at P1? You tell. If this is the P0, I'm assuming this is to be H. I will put the value later. So P1 is what? Say P0 plus H rho water into G plus x1. Sorry, water. This is the water column height. This is 36 plus x1 rho water into G. All right. And here, this is the atmospheric pressure. And this is equal to, this is x1 and x2. So what is the pressure at point 2? It is equal to P0 plus x1 plus x2 rho mercury into G. The P0 will cancel out. G will also cancel out. 36 plus x1 rho water is equal to x1 plus x2 into rho mercury into G will also cancel out. Do you remember the mercury water density? 36 plus x1 into 1 gram per cc. If you remember the mercury density, it is 13.6. Very first day, the water density and the mercury density I told you 13.6 into 10 to the power 3, and this is 10 to the power 3 kg per meter cube. Kg per meter cube. If it is given in the question, it is fine. Otherwise, you have to remember this. Now you may simplify 36 plus x1, right? And this the 36.6 x1 plus 13.6 x2. Is it clear or not? We have to find the x2. One more relation we should use, and what is that? Listen, this volume, this is the volume which is fall down, and this is replaced in this volume. Is it clear or not? You tell. This is fall down and this is move up. So this volume V1 and this volume rise in the volume V2. The fall in the volume in the left arm and the rise in the volume in the right arm are same, because the volume V1 and V2 is conserved. So what is the volume? Volume is A into x1. What is its volume V2? The 4A. This is the 4A into x2. So what is the relation between x1 and x2? x1 is equal to 4x2. We have to find the value of x2. So I am putting the value of x1. So this is 36. When you will simplify, 12 minus 6x1 is equal to 13.6x2. Now put the value of x1. The 36 minus 12.6 into 4x2 is equal to 13.6x2. Now I will simplify this. What will you get? I am writing this side. 36 is equal to 13.6x2 plus 12.6 into 4x. So initially it is, this calculation is a little wrong. This is 13.6. It is 50 and 13.6 will be, and this is 64. So please make it correct first of all, 64, and write this is 0.56 centimeter is the correct answer first of all, right? Now your doubt is how this volume V1 and V2 is same, right? Listen one thing, if this is the big volume, right? This is the big volume, this is the area A, and this is, suppose the area is 4A. Now initially the water is same, the level is same. Are you getting? So if you compress by some piston, suppose there is a piston, right, and by piston you are compressing this. If this goes to 1 meter down, so you tell me, is this, suppose if it is also equal to the area A, right, and the level is same. So if it is 1 meter down, if it gone down to 1 meter by pressing the liquid, so what is the rise in this liquid also? 1 meter up. Is it clear or not? Because the area is same, therefore this volume will be adjusted in the same height. Is it clear or not? But if this area is little larger, right, and initially the water is level is this, right, so if this 1 meter level if down by anyhow, suppose this is the piston, the area is A, so you tell me it will go to 1 meter or less, because everything is same, only this volume will compress and will fall, and this volume will rise. So it will be 1 meter similar to this, or less or more? Less. So how to find? Suppose the x meter. So in this case, what is the volume? This volume is fall down or it is compressed. So the same volume will move up. So this is the volume V2 and this is the volume V1. Are you getting or not? So the rise in the volume will be equal to the fall in the volume in the left arm. So this V1 is equal to A1 into x1 is equal to rise into the volume 2 is equal to A2. Suppose the area is A2 into x2. So A1 x1 is equal to A2 x2. Now you are getting this thing, right? Copy this. Also correct this. So now we are going to discuss the next case, the open tube manometer, right? Open tube manometer. This is the device used for measuring the pressure in the gas vessel, right? Used to measure pressure in gas vessels, right, or gas chambers, right? For example, this is the gas chamber, right, and the gas is filled over here. This is the gas, and the pressure of this gas is P, right? So you have to find you want to measure the pressure. So to measuring this pressure, you will take a tube, right? U tube like this, right? This is open at one end, right, like this. This is the, and the other end is connected to this. Initially, there is a liquid, right? The liquid. The both arm will be of the same cross section. The initially the liquid is in the same level, right? So now what will we do? The opening of this tube is very small as compared to, right, the gas chamber volume. Is it fine? So when this open tube manometer, here the liquid density rho you can understand, right? As you connect this, what will happen? The pressure start diffusing and it exert the pressure. It exert the pressure, then what will happen? Due to the pressure, right, this level go down, right? This level go down and therefore the same level move up. Is it clear or not? You tell. Now the pressure of the gas is P. So when the gas from the gas chamber, this is the very small opening. So what is the pressure at this point? At this point pressure is P. By measuring the height on the right arm of the U tube, and this is measured by the scale, right? The scale meter is over there mounted. So you can measure the, suppose this is the 0, 10, 20 like that. So you can measure the height difference in the left and right arm, and this is the pressure. This is the point 1, this is the point 2. So according to hydrostatics paradox, what is the concept? The pressure in the liquid at rest, the pressure in the same horizontal level in the same liquid are same. So P1 and P2 are same. So what is the P1? P1 is the pressure equal to the gas, right? This is the pressure of gas, you can assume. This is the pressure of gas at this point. Fine. And what is the pressure at P2? If this is the open to the atmosphere, P naught, if you go down, plus H rho G. Is it clear or not? So by measuring the height, you can measure the pressure of the gas inside this chamber. Is it clear or not? This is the absolute pressure. Absolute pressure. Absolute pressure means exact pressure. Sometime they ask the gauge pressure. Gauge pressure, right? What is the gauge pressure? Is the excess pressure of the gas above than the atmospheric pressure. So the gauge pressure is H rho G, right? So in this way you can measure the pressure of the gas chamber. Is it clear or not? Copy this. Okay, so in this question, right, this is the illustration. This is the water tank on the left side. This is also another water tank in the right side, right? And the water is filled up to some height, and the water is filled. Although the level of the water is shown as shown in the figure, right? There is a opening. The water is filled up to some height like this, right? This is the this tube is also considered to be the monometer tube, right? Like this. Whatever the name you give or not, you must understand the concept, right? This is the tube like this. Is it clear? And the liquid is over here. The density of this liquid is 0.9, right? Rho water. 0.9 rho water because the specific gravity is given 0.9, you can see, right? So you tell me if the liquid level over here is more and the liquid water level in this is less. Suppose this is the H1, right? And wait for 1 minute. So like this. Fine. And in this case, this is the another liquid. The another liquid is something like this. And the difference in the layer, it is 40 centimeter. Is it fine or not, you tell? And here the water, this is also the water, right? This is the water and this is the another liquid, right? rho water, this is also the rho water, right? So how to solve this? Using the concept of the hydrostatics paradox, right? In the two ways I will tell you, the simple ways or a little tough ways, both ways you have to choose, right? And try to understand, right? As given in the solution, I will also tell, but before that, what I told you, according to hydrostatics paradox, if liquid at rest at the same horizontal level in the same liquid, the pressure must be the same. Is it clear or not? So, can you tell me what is the relation if this pressure I assume to be P1 and this, the same horizontal level. Listen one thing, this is the same liquid, this is the same liquid. Is it clear or not? So, pressure at this point and the pressure at this point, because this liquid is same. Are you getting? So, at this point, if this is considered to be 40 centimeter, at this point P1 and P2 must be same or not, you tell? The same horizontal level. Alright. And consider this is the situation and the pressure. Suppose this is the H2. Calculate the difference of the condition indicated. Difference in the condition indicated if this is H2, right? And the pressure at this point, you can assume to be this is the height H1. Is it clear or not, you tell? Right, as shown in figure. Is it clear or not? Varsha, assume to be H1. So if there's a pressure P1 and pressure P2 is same, so what is the pressure at this point? You tell. Pressure at this point. It is P0. I assume this is the X, right? And assume to be Y over here, right? So at this point, it is the same liquid. So the pressure at this point will be the same. So what is the pressure at X? The pressure at X will be equal to P0 plus H2 into rho water into G. H2 into rho water into G. Is it fine? What about the Y pressure? You tell, if it is also P0. So Py pressure will be equal to what? Py will be equal to P0 plus H1 rho water into G, because it is also rho water. Is it clear or not? Fine. So if I write, if this is the P1, so what is the pressure at point X? You tell. Listen one thing. I am explaining this once again. This is the Px pressure, this is the Py pressure. So I think you have written the Px is equal to P0 plus H2 rho water into G. What is the Py pressure? Is it clear or not, you tell? Right. So this is the thing. If I assume this is the pressure P, you can assume to be P. And this is also the pressure to be P. This is the same. Although P1 and P2 are same. So can you write down the Px pressure? Please tell. On the left side, P plus H rho water into G. What is the pressure at P side, Py side, this side? P plus H rho liquid into G. Is it clear or not, you tell? Fine. And what is the Px pressure, you tell? The Px. What is the Px pressure? Px pressure is, what is the Px pressure? P0 plus H2 rho water into G. What is the Py pressure from this side? Say P0 plus H1 rho water G. Is it clear or not, you tell? Please, this is the equation 1, equation 2. If you subtract equation 1 minus 2, then it will be easy. So P0 minus P0, they will cancel. So H2 rho water G minus H1 rho water G, and this pressure will cancel out. So H rho water G, right, minus H rho liquid into G. Gg will again cancel out. So H2 minus H1 rho water is equal to H rho water minus rho liquid. So H2 minus H1 is equal to H rho water minus rho liquid upon rho water. So H is 40. The rho water is what? You can assume to be 1. Therefore, if it is 1, the rho liquid is 0.9 upon 1. So this is equal to 4 centimeter. I think it is better to do in this way. Right? Copy this. Okay. Listen. I should explain this once again, right?
Yes, sir.
Listen. This is the first method you can write. You tell me if the height, listen one thing. Although in the question it is not very clear what the difference they exactly want to find, but this is the tank 1, this is the tank 2, right? The total height in the water is tank is suppose H2, this is the H1. They want to find the difference in the height in the two water tank. Suppose the total height is what, H2, and the total height is what, say H1. Are you getting or not? So they are asking just the difference, H2 minus S1. They may be at the same level or like this, right? So ignore that. So they are asking the H2 and H1. So you tell me, can you write the pressure at this point? Yes. P naught plus H2 rho water into G. Is it clear? If this is the height H1 above this is indicated in the figure. This line is given in the figure, right? So what is the Py? P naught plus H1 rho water into G, rho water G, right? And you tell me, if I draw the line like this, if the pressure is P over here, P dash, and what is the pressure is P double dash, what is the relation you can tell?
P dash is equal to P double.
It is not correct. Why it is not correct? Because although it is the same horizontal level, but two liquid are not same. They are separated by some other liquid. So pressure at this point and at this point cannot be same. If it is same, then there is no pressure difference. There should be. Understood? So that is why I did not take the Px and Py are equal. Is it clear or not? Drawing the horizontal line does not always make sense that it will be always equal, but in the same liquid. For example, if this is the liquid, this is the same liquid. So at this pressure, at this point, the pressure is same. At this point, the pressure is same. Is it clear or not? In the same liquid, at every point the pressure is same. You are getting this thing or not? You tell. Right. So pressure at this point and at this point in the same liquid will be the same, whatever it is, we don't care. So if the pressure is P over here, if we go down, the pressure will increase or decrease? Increase. P plus H rho G. But rho is what? Say water. This is the water, this side. And in this side, Py is equal to what? P plus rho liquid into G. So is this Px or Px, Py are clear or not? Also the Px we found from the left column. This is the Px. In the same way, the Py also found with the help of this, the right tank. Right. So this is the Px and this is the Py. So if you subtract them, P naught and Pp will cancel out. So what will left over here? H2 minus H1 rho water and H rho water minus rho liquid, and the calculation is simple now. The previous case it was very little tough, right? So before doing this question by another method, I will give you another question. Listen, always one thing remember in mind. Suppose the density is rho and this is the P1, the P2. So if we go down, the pressure is increased. P1 plus H rho G is equal to P2. You understand? It is very simple thing. Are you getting? Yes, Varsha. Please suppose this is the liquid. This is the one liquid. Right. This is the another liquid. Right. And this is the another liquid. Is it clear? at the pressure is P naught, then this is the H1 rho 1, H2 rho 2, S3 rho 3. Is it clear or not? So this is the point A. Listen, I want to write the pressure at this point P dash. So the pressure equation, monometric pressure equation, how to write? This is the P naught. Say move down. P naught plus, tell me, rho 1 G plus S3 rho 3 G. Listen one more thing. Now this is connected to some other level like this. Is it clear or not? Now the some other liquid is over there. The density is rho 4. This is the H4. So now I have written the pressure at this point. The pressure in the same liquid is the same. So if we move up, then what to do? Plus or minus? If we move up, minus H4 rho 4 G is equal to, if it is atmospheric pressure, it is atmospheric. Is this equation you understand or not? All right. This is the monometric equation of pressure. For example, I am giving you a good example so that you can understand this concept in a correct way. Right. Suppose here this is the gas chamber. It is connected to the gas chamber. Right. This the pressure is P1. Right. And now this is the one liquid of the H1 rho 1. Fine. Now there is another liquid. This is the H2 rho 2. Right. Now this liquid is filled up to this level. This is the water, suppose this is the water, right, and it is filled like this, right, and there is another liquid like this. This is the H4 rho 4. Are you getting or not? The difference is this H. Suppose this is H4, and this is connected to the another gas chamber P2, right? So how to write the equation? Listen, if doing in this way it will be very tough, but writing in a line it is very simple. When you will go down, the pressure will increase. When you will move up, decreases. By what amount? Say H rho G. But keep it in one mind, keep one thing in your mind, at the same horizontal level, in the same liquid, if the liquid is at rest, the pressure will be the same. Listen, this is the same liquid. Suppose this is the water, and the water is filled up to this point, right? Although you may assume this is the H1, right, and you may assume, suppose this is the H2. In this way, the complicatedness they will increase. Suppose this is the H1 and this is the H2. So listen one thing. I will start the monometric equation from this point. So this is the P1. Yes, please tell me. P1 plus H1 rho 1 G plus H2 rho 2 G. Now how to do? The one way is that you may write like this, H1 rho water G. Then this pressure is the same or not? Then what to do then? Then what we have to do? H1 rho water G. Is it clear or not? Then tell me, minus rho 4 G is equal to P2. So you understand this way? All right. Yes. This is H2, right? Getting or not? So this is the thing. Also listen one more thing. P1 plus H1 rho 1 G plus H2 rho 2 G. the H2 is greater than H1. So can I write in this way? H2 minus H1 rho water G is equal to minus H4 rho water rho 4G is equal to P2. Is it clear or not, you tell? And what is H2 minus H1? This is small h. So minus H rho water G minus H4 rho 4G is equal to P2. P1 plus H1 rho 1G plus H2 rho 2G minus. Is this equation you understand or not? What is the small h? Small h is the difference between H2 and H1. So even they have not given this value. Please look at the board. So how to write the equation? Say P1. Please tell. P1 plus. Plus. Listen. And now it is the same liquid. In the same liquid, the pressure at this point will be the same or not? So the pressure at this point is the same as that point. So when you will move up, minus H4 rho 4 is equal to P2. So if H1 or H2 is given, you may write like this, then you may write like this, if this is H2. But it is better because anything will be there. It is better if the liquid you are getting the same. So you draw the same horizontal level and write the equation from here, then go up. So this is the equation of, right, pressure equation of monometric, monometer, right? This is the answer. So only you can write this, or you may write also this, right? Copy this. Okay, so I will do this question by the writing the monometric pressure equation. Now you can tell. Listen, I think the picture photo figure is clear. So if I start from here, I will move like this at the same horizontal level. Then I will move like this. This is the same liquid. Then move like this. Then move like this. Right. Tell me, P naught. Yes, this is the height H2. P naught plus H2 rho water G. Right. This is the same liquid. So the pressure at this point will be same. So when you will move up, what? Minus H rho. Whose rho? Whose rho is this? Water G. Then this is the same level because this is some liquid. So now move down, plus or minus? Plus H G. And now it is the same liquid. Move up, minus H1 rho water into G is equal to P naught. Is it clear or not? Now it's look better. It is easy. P naught, P naught. So H2 minus H1, H2 minus H1 rho water. G will also cancel out. This will go this side. H rho liquid minus H rho water. H rho liquid minus rho water. H2 minus H1. The rho water comes in denominator. You will put the value, right, and you will get the answer 4 centimeter. Is it clear or not? Tell me. This is called the pressure equation, monometric pressure equation, monometric pressure equation. I will start from here, then in the same liquid, move up, go down, then move up. That's it. Copy this. So in the illustration number 8, what is this is the open at one end, right, and this is closed at the other end. Fine, like this. This is the closed. Here the liquid is of density D2, and this is the another liquid, right, and this is the liquid till at this point, right, and the density of this is D1, and the pressure in this gas is P, and this is what? Open to air, P naught. Is it fine? So this distance is y, which is 25 centimeter. All right, and this distance is also given as the x 26 centimeter. Is it clear? Although the density D1 is 13.6 gram per cc and the density is given 2 into 13.6 gram per cc. So I'm writing in terms of the mercury. D1 is what? Say, okay, density is D1, right? Although you should remember the pressure in terms of density of the mercury, H rho mercury into G, right? It is 13.6. So the H comes to be 76 centimeter of Hg. You should keep this in mind. So can you write the monometric pressure equation from starting from here, then here? This is the same liquid and this is the pressure P. So can I write start writing P naught plus tell me P naught plus H rho G Y rho G, then plus X rho G. At this point, same pressure. I cannot write the pressure at this point is same. This is the same liquid. So therefore, in the same liquid, the pressure at this point is same. The pressure is not at this point. You must understand first of all. This is the confusion, right? So this is the thing. So what they're asking, find out the relation between P and PA. So this is the atmospheric pressure, PA. The Y and Y value is what? 20. What is the Y value? It is 25. D2. D2 is 2 into 13.6, or you may write rho mercury, right, into G. What is X? 26 rho mercury, because it is equal to what? Rho mercury. It is equal to 2 times of rho mercury, and this is the pressure. So this is the atmospheric pressure. 25 दूनी 50 plus 56. This is the 76. 76 centimeter rho mercury into G is equal to pressure. What is the atmospheric pressure? I told you, the 76 centimeter rho mercury into G plus 76 rho mercury into G. Is it clear or not? So this is equal to 2 times 76 rho mercury into G. Is it clear or not? So this is the pressure in this side. And what is this? This is the 76 centimeter rho mercury. It is the pressure of the atmosphere. So the pressure on the left side is the twice of the pressure of atmosphere. So what is the relation between P and PA? The P is equal to 2PA, it is coming. Please copy this. Is there any confusion between writing the pressure? Yes, the pressure, atmospheric pressure is 76 centimeter rho Hg. Also, you can write in this way. Is it clear or not? So that is why the data is given in such a way. This is the twice of the density of mercury. This is the density of the mercury. So that this pressure comes to be like this. And this is the atmospheric pressure in terms of 76 centimeter of Hg. So this is the relation, right? Now you can read the illustration number 9. Read the question. Yes.
Find out pressure at points A and B. Also find out.
Very good, very good. Listen one thing. This is the okay. Wait for 1 minute. Although this is not like this. Actually, this should be the height h like this, right? So if the rho 1 is density, the length L, right? So if this is the atmospheric pressure over here, right, this is also the atmospheric pressure over here. So by moving up and down, the pressure will increase or decrease. Are you getting or not? Like this. So this is the rho 1, this is the rho 2, and this is the rho 3. I think you understand this. Fine. So I am starting from writing this. Although you will move this, but the height is this. If this angle is theta, this is also theta. This is suppose the x or the h dash, you can assume. Sin theta is what? Say h dash upon L. So what is the h dash? H dash is L sin theta. So if this is the point A, this is the point B, right? I'm starting from here, moving up. Write the monometric pressure equation, P naught. Tell me, plus or minus? You are moving up, plus or minus? Say minus, how much minus? Say H1, rho 1 G. Is it clear or not? Now, come down, plus or minus? Plus. How much? Say H dash, rho 2 G. Is it clear or not? Then,
So that value will give us both.
okay, it is rho 3. It is rho 2. I will write rho 3. Then, minus H. This H is given in the question, right? Rho 2 G is equal to, you are getting this equation or not, you tell? So it is cancel out. So H dash, G will also cancel out. H dash rho 1, H dash rho 3, right, minus H rho 2 is equal to 0. So the sin theta we have to find. So if H dash is common, rho 3 minus rho 1 is equal to H into rho 2. What is the H dash value? Say L sin theta, rho 3 minus rho 1, H into rho 2. So the what is the sin theta value? Sin theta value you will get H into rho 2 upon L, rho 3 minus rho 1. I think you are getting the solution. Please copy this. Varsha, you are getting this solution or not?
Yes, sir.
Right.
Sir, I have a doubt.
Yes, please.
Sir, why can't we take same?
No. Actually, the mistake in the figure, little mistake, right? It is just copies from the BM Sharma, and BM Sharma, few mistakes, printing mistakes are there. If the H and H both are same, so H will be the same. Everything will be the same. This H dash is different. That is why I make it correct. There is a mistake in the figure. Either you may take it less or more, but they are not equal. Are you getting?